Hello, everybody. Great to see you. Thanks for joining us. I hope if you're new, welcome. If you're a recurring guest from part one, welcome back. Hope everybody had an enjoyable spring break. Little opportunity to catch up on what you were working on. Any highlights from the last week for those of you who are repeat guests? Got a new job. Congrats on that. Yasmin, well done. I think you might be the only person right now in the last week who's gotten a new job, so congratulations there. I assume that's San Diego and not South Dakota. I think your rent might be slightly different in those two places. Good job. Passed your discrete math class. Excellent. Should we have a discrete math class as part of what we do here? That would be a nice preview of what we're going to do. Maybe, hopefully soon. Starting a new internship. Excellent. All right. Congratulations there. Well done. All good news. Nobody wants to share any bad news. Yeah, I had the opportunity to do a little bit of travel myself. My spring break news was I got a chance to hold an alligator. And it wasn't a very big alligator, but it was nevertheless mildly scary. I was thinking about it, especially because people are mentioning jobs and internships at a time when, I don't know, our own students are really struggling these days in the job market and finding opportunities. And yeah, I even think about my own employment. Like, at what point do I get replaced by AI, right? I don't know. Maybe soon. And then I watched a guy reach out into water and like scratch a 13-foot alligator on the top of the head and feed this alligator with his bare hands. The alligator was named Pierre. And I thought, it's going to be a really, really long time before that guy's job gets replaced. As terrifying as it is, he might be the most secure person in the AI job market that there possibly could be. But all right. All right, we're going to move towards getting started. Remember, there's a soft deadline this week for part one of Cognitera. So if you've been following part one, kind of the guidelines for keeping up are to make sure you get that complete this week. If you're following the class asynchronously or you caught up to what we're doing as we're going through it, we're going to keep the course materials completely open, and you'll still be able to get a certificate for completing part one of the course whenever you do it. So I've had a couple folks reach out to me with that question. So if you're a little bit behind, it's okay. I love that we've had several hundred people go through the first cohort of the course, and I've removed the deadlines from previous weeks or previous chapters. So we're basically transitioning that course to asynchronous, and we're going to have the same sort of thing for part two. So we've got this synchronous run of the course, and the opportunity is you can follow along with us live. We still have office hours. You can come to the live streams and interact and these sorts of things. It's a great way to just keep up, but we're always going to have the course open and you can complete it at your own pace. And the same goes for part two. Now, that having been said, to those of you who completed our survey, thank you very much for doing so. It was illustrative that it's a good opportunity for me to make our pace a little bit more steady. I wanted to make sure that we had 2 sessions per week when we were going through the part 1 materials, because a lot of times folks have seen that before or seen it in some form or fashion, and it gives us this nice rhythm because, I mean, as you saw, we spent a lot of time building up from first principles all the way up to just to be able to do two-dimensional arrays. And we have so much of the foundation of everything that we need, and we can start seeing some advanced things. And it also gives us a chance to sort of just catch our breath and control the pacing a little bit. I also found that people seem to want like extra streams on additional sorts of things. And in particular, like, how is it, one of the things that I think has been the most fun is when we frame a problem and we go through and we just start solving the problem and we see how to go about solving a problem. I think that's more fun than learning the syntax of Python, even though that's really good. But what we're going to do is have special streams that are devoted to just the problem solving side of things. And a lot of these will start with stuff that we've already covered. If you followed us for part 1, we're going to sort of go back in time a little bit and start solving some more elementary problems, and then we're going to build up. In particular, the problems I'm going to choose for this collection of streams that we're going to do are taken from the Rosalind platform for learning at bioinformatics, which is about 15 years old now, and is a collection of problems that I worked with a team of folks. I was a co-founder on this project, but the bioinformatics challenges are almost entirely written by the PhD version of me from years ago. And I've written all of these problems. It's been a very long time since I've solved any of them. And so I thought it would be cool to just kind of go through steadily. I'm calling it a Rosalind slow run, because the idea is not to go through very quickly, but to go through starting with just the first problem and then solve these as we go. So those streams are going to replace or kind of substitute what we were doing on our Thursday streams. And I'm also going to offer those at a time that's a little more amenable for folks who I know have wanted a live stream but are in a time zone that it's not amenable for US-based times. So I'm going to be doing those for the next few weeks, Thursdays at 11 a.m. You may have seen that information from me via email. And if not, or if you're new, we have tons of links that you can check out. So in our description, make sure you see we've got an email list that you can join. We're going to have tons more information coming out soon, including the launch of new courses soon. And one of the new courses that we'll be launching is my own course called Great Ideas in Computational Biology. So we're going to have that rolling out in the next couple months. And of course, we have a Discord. We have an ebook that you can get. You can either get that as a subscriber or as a standalone purchase. And that accompanies all of Programming for Lovers, and we're constantly updating it. And we also have our projects launching this week. So we have like 20 people who are going to be working on projects built off of what they've learned in part 1. All of these projects are scientific in nature, and a lot of them are around, like, here is a paper that was a real scientific result, maybe 3 decades ago, and you can actually code up everything that you need in order to replicate what this work was. So that's really cool. We're doing our first cohort of it right now, and we definitely will have another cohort of projects in a few weeks' time once our initial cohort goes through. And we'll also probably have a collection of projects accompanying what we do in part 2. So what's nice about part 2 is you can do even deeper work and start representing things with object-oriented programming, but we'll need to go through that first, and then we'll have a project accompanying it for our subscribers. So as always, I think that's a great transition to what we're going to do, which is object-oriented programming tonight. Like and subscribe if you haven't already, please. And tonight we're going to talk about, what we want to do is to build this gravity simulator. So we want to be able to take a system, whether it's the moons of Jupiter or a collection of like hypothetical celestial objects, and simulate the force of gravity over a period of time, and then see how the motions of the moons or the planets or whatever we're simulating changes over time. And it turns out we can do some absolutely beautiful work there. When we look at something like the moons of Jupiter, as you might expect, things are just mostly going to go in circles or elliptical orbits. But we can also build some hypothetical simulations of just 3 bodies that produce absolutely beautiful animations that I think are just as pretty as what we saw when we worked with cellular automata. So we're going to do the engine for that next time. And we've, in a lot of cases with what we've done, you have some initial work that builds us up to something. And in the case of the gravity simulator, it's cool because that might sound like a really complicated simulation that we have to run, but all it takes is a little bit of physics that you can check out on our Programming for Lovers website, where we have the reading that accompanies what we're doing. So if you're a little rusty on physics, you can review that there. I'll probably explain it a little bit as we go through it. And you'll also just need a little bit of object-oriented programming. So we're going to make this transition towards object-oriented programming today to prepare us for implementing that gravity engine soon. But tonight is all about objects, and as we always do, we're going to start with the foundations of everything that we need, and that's where we're going to begin. So as always, I said like and subscribe. Let us know if you have any questions in the chat. I'll be here, and thank you for joining us. All right. To get started, I have some starter code here, and our starter code is taking us back to how we've written starter code throughout the course. And you'll notice that we have our special 2 lines at the bottom that say, run the code that's contained in main. And in main, I simply have a short print statement. So how we're going to start is, and I should say this is in a shapes folder. So this is a main.py file. It's contained within a shapes folder. And that's within our Python src directory. So our directory is starting to get really big, which is exciting to see. The question then is, how is it that we work with objects? And by objects, I'm thinking about everything that we've done up to this point. We've been able to do quite a lot, but we've worked with integers and floats, and we've worked with strings. We have maps that associate keys with values, and we have arrays of values that we can fill and so forth. All of these are sort of built in to how we work with things. And we've started to make this very brief foray into abstraction when we talked about the notion that, well, sometimes I have a 2D array, but then I also want to think about this as what I might call a game board for simulating the game of life. What we want to do is make this transition towards having a more concrete notion of what an object is in a programming language. And on the highest level, we could think about an object as a container that stores a collection of other variables. And so, for example, if I wanted to define my own object class, and I were working with an example of just trying to generate shapes. So, for example, I'm the developer working on the first version of Microsoft PowerPoint, and I need to have shapes on a hypothetical canvas, which is a concept that we've already touched upon when we've talked about how it is that we produce drawings and animations in Python. But say I wanted to do this myself. So I would want to declare an object type that's a rectangle. So to do that, I've got a statement class, which indicates that I'm about to declare an object. And then I have the rectangle, which is just the name of the object that I have. And the Python convention here is for objects to be named using a capital letter. So most of the time when we have functions, we have snake case, where everything starts with a lowercase letter, and then there are underscores separating words. But when we define an object, we always want a capital letter. This is just convention. And then the rectangle contains, think of it as a box that's got a bunch of variables in it. And those variables, in some sense, abstractly define what it means to constitute a rectangle. And if we think about, here's a hypothetical picture of a few shapes, and I'm going to come back to this when we talk about moving shapes, but imagine that we have this particular rectangle here, or this circle here. Then we can represent the nature of this rectangle, and we're going to have more than this. So we're going to have a fill color, we're going to have a stroke color, and a thickness to how thick we want the boundary to be. But we also want to represent, like, where is the location of this object? Where is this shape on our canvas? And it's a good introduction to abstraction, because our brains think about this rectangle as living in this particular place and taking up, occupying sort of this area. But we can represent this with a small amount of information. One of the things that we might do is pick a point of the rectangle. Maybe it's a corner, maybe it's a center of the rectangle. Say it's the lower left corner. And if I know that information and I know the width and the height of the rectangle, I can nearly draw it. The only other thing is this rectangle has also been rotated. And so I need to make sure that I have some parameter that allows for that rotation. In the case of the circle, you might or might not remember from your geometry class that the circle is defined as a center. So an x1 and y1 point constituting the center of our circle. And then the outside of this circle is all the points that are some fixed radius from that center. So we're going to use this notion that I can understand a circle with just 3 pieces of information. I can understand this rectangle as a shape with just 5 pieces of information. And then we want to express this to Python via our class definition. So before I do that, the first thing I should say is when we establish the fields of a rectangle, and in Python these fields or these variables that are associated with it are called attributes, we're going to use a special type of function called a constructor. And the constructor will be a function, so we use the def keyword to indicate that it's a function. I have a double underscore, and then the word init, and then another double underscore, so it's a little bit of the similar sort of convention as what we have here in our bottom 2 lines. And then parentheses, and inside of the parentheses we take self. Okay. And I'll explain more about this here momentarily, but I want to focus on these fields, or what Python calls attributes of the object. And if this is a rectangle, then I said we want to have 5 things. I can access these fields of the object by saying it's the self, so this is my current object that is being referred to as self.width equals some default value. This is self.height is equal to 0.0. And I said we're also going to have some x1 value, a y1 value that's associated with, this particular point of the rectangle that I'm storing. And then we're going to have a rotation parameter that tells me how much to rotate it. So in each of these cases, I'm indicating that the current rectangle that I'm going to produce needs default values for all of these. And if you've seen objects declared in a slightly different way in Python, that's great. That's because Python provides a lot of different ways of doing this, and I want to show you a couple. But this is the standard classic way of producing an object. So we say the object is called a rectangle, and when we create a rectangle, we need to set 5 things about it, and these are the defaults that they're all going to get. So we're going to have the critical corner that we care about is going to be at the origin, and we're not actually going to set a width or a height, so it's not going to have any width and height to it at the start, and it's not going to be rotated at all. We can set these values differently after we've created a rectangle, but this is where we're going to start with. I should also say that just as functions in Python have doc strings, documentation strings that we work with, the same is true of class declarations. So I should be careful here to make sure that I say what a rectangle is. And now you might understand what a rectangle is and say, Philip, this is not so complex. I know I'm just storing this with 5 things, and I could add things to this like the fill color, as I said, and this could become more complicated. But as we move towards more complex applications, we want to make sure that we're documenting what we do in the same way that we have already started writing some pretty intricate functions, and it's good to indicate precisely what it is that they do. So in the same way as what we worked with functions, when we have a doc string for an object, we have an initial line that simply says, what is it that this object is? So this is representing a rectangle in the plane. And then we might specify specifically what these attributes are. So there's one which is the rectangle's width, and this is a float. We also have the height of the rectangle, and this is a float. So we want to specify what these types are. And we have x1, which is going to be the x-coordinate of the rectangle's, I'm going to say corner, also a float. Y1 is going to be the same. And so this will just going to be the y-coordinate of that particular point. And then we have this rotation parameter. And we're not going to work with that so much. I could specify that in degrees or radians. As long as I make sure that I agree on what I want to do in advance, it's nice to specify this to the user. Of course, we want to work with a rectangle once we've been able to produce it. And we also want to declare other types. So while I'm declaring an object, I'm going to go ahead and declare a circle object too. So you could declare any shape that you want. A rectangle and a circle are probably the easiest to conceptualize representing them, and they give us two different shapes. And as we talk about more advanced concepts in object-oriented programming, you might think, well, what's the big deal of using shapes? It's because they give us this nice, simple, concrete, understandable, visual concept for object-oriented programming, and so we'll see more complicated ideas applied to them. But for now, I should say not def circle, but class circle. And we're going to have a doc string for it as well. And in this case, I'll say it represents a two-dimensional circle, or circle, in the two-dimensional plane. And the attributes of this thing need to be, well, we want to have, in this particular case, we want to have an x1, we want to have a y1, and we want to have a radius. So the radius is a float. X1 and Y1 are floats too. It's nice that everybody here is going to have the same type. And this is the Y coordinate of the circle center. And that's a float. And for X1, I'm going to say the same thing for the X coordinate. All right. So we'll need a constructor. And in the same way, I'm just going to copy mine down because we're setting very similar fields here. I'm still going to set self.x1 and self.y1 equal to some default value, and I'm also going to set the radius. So this is just explaining what are the attributes that define the critical features of how we think about a rectangle or a circle. And it's important to appreciate that, and I think that this point is debatable in the era of AI, but that at least until recently, the computer is not necessarily thinking about these shapes in the same way that you or I might. They're not conceptualizing precisely what a circle is, or exactly what constitutes the notion, the romantic notion of what is a rectangle. The programming language is just built here to say a circle contains 3 attributes and they're all floats. And when you create a circle, they all get set to 0. And the rectangle is these 5 attributes. And when you create one, they all get set equal to the default value of 0. The point remains that it would be nice to create specific instances of these objects whose types we've already declared through these class declarations. And so let's go into main then and create a circle or a rectangle. I'll actually create one of both. So I'm going to create a circle called my circle, and I can do so just as I set any other variable name. I can do so by saying, here's the name of the variable. And in this particular case, previously we might set an integer equal to 3 or this equal to some list that we start off with. In this particular case, I'm creating a circle. And so I can simply do so just with circle and then open and close parentheses. I'm going to create a rectangle that I'm going to call R. And they're all going to get these default values. So all of their attributes all get the defaults, but we can change them. Okay, so why don't we do that? And I could set, for example, my circle dot x1. Let's move the x coordinate of its center to 1, and let's move the y coordinate of its center to 3. And let's make sure that it actually is a circle. So it starts off with 0 radius, which is kind of weird. So let's set its radius equal to 2.0. And then I want to change some attributes of R as well. So I'm going to set r.width, and that's equal to 3.0. And then we're going to set r.height too. So let's set it equal to 5.0. So we are already going to know that the area of this rectangle is equal to 15. Now this isn't the cleanest. One of the things that you might imagine is, why would I create the circle or rectangle and then I go through and I change their attributes? It seems like would be a lot simpler if I just, like when I defined or declared, here's my circle, here's my rectangle, I could directly set the attributes that I really care about. And let's see how Python does that with something called a parameterized constructor. So these allow us to set the fields at instantiation, meaning when I say, here is a specific instance of this abstract notion of a circle, meaning go in and create these 3 fields or attributes for me and associate these variables with this variable, my circle, or here is a rectangle that I'm calling R, it would be nice if I could simply specify the attributes that I want to start with. So I will change how I write my constructor functions. I am still going to want to specify this special word self, which means for the rectangle that I am declaring, the one that I'm creating, it's just getting called self. But I can also specify these default parameters within the constructor inputs. So I could say that the width starts off with a value of 0.0, and the height is the same. And you'll notice that this should look similar to what we've seen before, because when we set type hints, right, these are ways of indicating to a function that a certain input should probably have a certain type. So you're used to seeing width :float, and this equals 0.0 is just specifying what the default value of width should be if somebody doesn't specify it. So I'm going to go through and establish what are each of these different attributes, what are all their types, and everything here is super easy because they're all floats and they're all getting this default value of 0.0. Okay. One other thing that I want to specify is, notice that this is very much a function, and we're getting these type hints to the function, and so the function is not really going to return anything, so I should specify that as well. So in the fanciest way of writing a parameterized constructor, you actually specify that there's no output of this constructor as well. You're producing a rectangle, but it's not outputting anything. And now what we could do is to say, well, notice that I've got these fields too, or these lines that are setting things equal to 0.0, and I no longer want to do that, because how this function is going to work is it's going to allow the user to input specific values for the width and the height, x1, y1, and the rotation when this rectangle is getting created. And if they're not specified, they're going to get set to 0.0. But if they are specified, then I need to set the attributes equal to them. So I'm going to set self.width is equal to this width parameter. I'm going to set self.height is equal to this height parameter. Self.x1 is going to be this x1, and you can see that the parameters here are changing color because they're getting used, which is good. And we want to set the rotation. And so we can do the same thing with a circle. So inside of the parameterized constructor, I'm going to specify x1, y1, and not the rotation, but the radius. It's fine to set them all to default values. So I'm going to change this to say radius. But I have x1, y1, and radius. And so I'm going to set self.x1 is equal to whatever the x1 value is, and so forth. And that gives us our rectangle and our circle. I want to show how this works. Before I do that, I'm going to point one more thing out, which is that notice everything here is similar to what we've already seen when we've worked with functions. As I said, you've still got doc strings. You still have type hints when you're constructing a circle or you're constructing a rectangle. All that's the same. And we would like to go in and say, I want to create a rectangle, and I want that rectangle to get the values 3.0 and 5.0. Now, if I do this, my first question would be, there are 5 attributes here. I only actually care about setting 2 of them. And so which 2 are going to get set if I change my declaration of the instance of this rectangle that I'm calling R to receive 3.0 and 5.0 as the inputs? What do we think is going to get set when I specify 3.0 and 5.0 as the inputs to that function? Some votes for x1 and y1. Some votes for width and height. Okay. The best answer, I like the best answer that says, well, there's nothing special about x1 and y1 versus width and height, and Python's not able to infer what it is that you want these things to be set to. What it will do is do the correct answer, which is whatever the first 2 things are. So whatever the first 2 parameters happen to be, that's what is going to get set. So if I had set x1 and y1 first, well, that's what would get set here. But in fact, the answer is going to be width and height because these are the first 2 parameters that are given to this constructor. So this will specify a rectangle that has width 3.0 and height 5.0. Similarly, for the circle, let's go ahead and specify all of the remaining ones, or all 3 of the attributes. So I'm going to say the circle is going to start at an x1 center value of 1.0, a y value for its center of 3.0, and let's give it a radius of 2.0. So in this case, the rectangle has 5 fields, but we only set 2. And I will say that the width and height are set. And what happens to the remaining fields, or the remaining attributes? Well, they're going to get the defaults. So all of those in that particular case are going to be 0.0. And now I don't feel like I have to set these values that I set before. I can simply declare my circle in R and set the parameters as we go. So this is, I think, a far better way of producing a circle or a rectangle or an object in general, which is to set its attributes when you declare it. But there is something missing, and I had started saying what it is, which is that when you look at how the classes are created here, everything looks Good. It looks straightforward. It's familiar. We have a doc string, and we have this constructor that's going to create the circle that we care about, and it's got these things that look quite similar to type hints with default values and so forth. But then there's one thing that we're used to doing in terms of good programming style that we have not done here. And my question is, what is it? And what is it that we need to add? BZ says, technically I need a none here. Okay. Fair point. Mea culpa. I should say none. There's something else we probably should think about, though, too. Yeah, it's not technically needed. This is just making sure it's as complete as possible. Good, though. That was not what I was getting at. I was thinking about somebody declaring a circle or declaring a rectangle. What might go wrong? All right, 2 for 2 for orient. Good. We probably need to check errors because I could be mean. And we have some ideas of how we might check the errors. Great. I could be mean and like give it a radius value that's negative. Now, maybe the mathematicians would be comfortable with this, but I don't think we're going to be comfortable with drawing a circle that has negative radius. And similarly, now that you go down this rabbit hole, you might think, I could produce a whole lot of checks here. Like, for example, I want to make sure that the user is actually putting in a valid value for the radius and isn't just putting like a string as the field. So you don't want to be in a circumstance where you allow the user to do something like this and set its radius equal to the string hello. So you'd want to make sure that you have checks for that. And we're not going to write a very thorough set of checks, but I am going to point out that if I want to make sure, I'm going to do a very natural check, which is like for the circle, I want to ensure that before I set these attributes, we should probably check that the attributes are valid. And one thing that I might do, for example, is to say, all right, if the radius is negative, well, then I want to say, let's raise a value error. So I should say error, circle radius, should probably be non-negative. And I could imagine doing similar types of checks in the case of the rectangle, where I certainly I would want to allow myself to have a negative x1, a negative y1. You could be moving left or moving down, that's fine. And the rotation even could be negative. So instead of rotating it one direction, I could be rotating it the other. But I also want to make sure that I'm checking things appropriately. So I'll say, and I'll combine it into one check. So I'll say if the width is less than 0.0 or the height is less than 0.0, I'm going to say the radius, or not the radius, the rectangle width and height should be non-negative. And now we feel like we have safe values. And of course, you should probably also check that each of the input parameters has the appropriate type with something like isInstance. Okay. But I don't want to distract us too much from learning about the principles of object-oriented programming that we're going to need to apply to a gravity simulator. And so I'll save that for now. For now, what I'd like to do is to say, let me prove to you that when I've created these shapes, that they actually do have the fields that I've said that they have. So in particular, if I've created a circle and I said the circle center should be at 1 and 3, and it should have a radius of 2, and the rectangle's width and the height got set to 3 and 5 respectively, but the remaining attributes get these default values of 0.0, I should probably just print it. Now, let me remove this statement. So say, let's print the shapes. And I'm going to say, let's print R, and let's print my circle. And as you might expect, what we probably should see is if Python is thinking about the rectangle as containing 5 attributes, if it's thinking about the circle as containing these 3 attributes, then hopefully we would see each of those things get printed. When I run my code though, so I make sure I save my code as always, and make sure that I navigate into the appropriate directory. So I've got Python as my directory here in VS Code. So that's showing me that here. And I can navigate into src/shapes. Once I'm there, I can run my code by saying Python 3 or Python on a Windows machine, and then main.py and click enter. And what you see is not what we might anticipate, which is here are the fields or here are the attributes of each of these shapes. What we see is, well, I printed a rectangle and I printed a circle, and it says, yeah, it's in main, and it is a rectangle object, and then blah. The question is, what is this? Anybody know? What is the information that's being conveyed here by saying we have a rectangle object at this particular thing? What does that mean? And I would imagine you probably have different values. You're going to see the same thing up to here, but then this is probably going to differ on your machine. Good. A couple folks have it. Great. So each of these things are memory addresses. And we're going to talk more about that when it comes to memory management. It turns out that the 0x is an indication to us that this address is being represented in a very special way. And we'll talk more later about what exactly that means because, well, we're going to have to do a little bit of math, but it's going to be very fun math. And it's going to allow us to understand exactly what's going on. But for now, I just want you to think that what this is telling us is Python is saying, hey, I made you a rectangle, I made you a circle, and I put it at this specific location for you. So on your computer, it's being stored at this particular location. And that's why you probably have a different value than I have for these two things. But you'll note they're kind of similar. So without understanding more about memory management, I probably would be able to infer that they're going to similar places inside of the RAM on my computer. But that's all I'll say about that for now. For now, I want to come back to object-oriented programming and say, well, can we not get this memory address printed? Like, wouldn't it be nice if it just printed what we would hope it would do? And Python is going to say, that's great. You need to write the function that's going to do it. So classic Python is to say, you have to have your constructor, and it's nice to have parameterized constructors with error checking, sure. But you also need a special function if you want to print an object. You need a special function called REPR. So it's going to have similar syntax to what we've worked with here with the constructor. It's going to have a double underscore before and after it. And it's also going to take self as the input. But it's actually going to have an output. So in the case of the rectangle, let's do the rectangle first. So we are going to place this function, again, beneath the docstring. We can put it after the parameterized constructor, but it's a function. It's named double underscore REPR, double underscore. It's going to take self as an input. And in this case, it's going to return a string. So think of REPR as a representation of a particular object. Now, the other thing I would say is that we're getting a very brief glimpse of something called methods that we're not going to talk about today. And as we go through object-oriented programming and we see another application of it, we're going to come back to this. And why this is like a function of self is all going to make perfect sense. But for now, I just want you to think about this as every object benefits from, or every object class benefits from having two of these special functions associated with it. And one creates an instance of the object that we've worked with, and REPR is going to represent the object as a string. And here's where we could do something like, return a string that's a very fancy representation. So I could use f strings for this, and I'll say we could have rectangle width equal self.width and height equal self.height. And I will show you this for now. This is all I'm going to actually produce for the moment. So I will show you how to call this function. And so instead of printing R, in this particular case, I'm going to print REPR of R. And when I save that, and then I hit up in my terminal and I run, you're now going to see that this has been printed in a nice fashion. So whereas the circle is still getting printed with the memory address, the rectangle is getting printed like this. So that's kind of what we want. And it means that we have to write this f string to format the rectangle in this nice way. But it's printing, we have a rectangle, here's what its width is, and then you specify the width attribute, and here's what its height is. So I could say more about this. I could even split this over multiple lines and give it two f strings and say x1 is equal to self.x1 and y1 is equal to self.y1. And then I guess I need a rotation too. And so now I've specified those as well. So when I save that and I run it, you're also going to see, let me make sure I have a space here just for consistency. So when I save this and I run it, you'll see the circle is still just getting a memory address, but the rectangle is getting width and height equal to 3.0 and 5.0 respectively. And then x1, y1, and the rotation are all getting those default values because we didn't set them. So in main, remember that I set 3.0 and 5.0 as the width and the height, and now you can see these other values are not actually getting set. I probably should move this parenthesis here to here. That might be better. Okay, so it's a rectangle with these 5 attributes. So far, so good. And I'm just going to very quickly do the same sort of thing for the circle. I'm just going to copy this entire thing down because it's still going to be a repr function. It's still going to take self as input. It's still going to produce a string. And I'm just going to put it in the same place. So it's going to return, in this particular case, circle. And I'll say, maybe let's specify the radius first. It doesn't matter what order you do these in as long as you specify what the attributes are. And I'm just going to join this here to say x1 is self.x1, y1 is self.y1, and I don't need a rotation. And then when I save that and I run, we'll see now the circle gets set, or gets printed, I should say, saying here's what the radius is, and here's what the x1 and y1 values are. So it appears to be working. That's what we had said before, even though I changed the order in which they're printed. When we created the circle, x1 and y1 were 1 and 3, respectively, and the radius was equal to 2.0. All pretty good. Now, you may have the criticism that this is pretty hideous. And if you feel that way, don't worry. I feel that way too. And I would just say to sit tight. So you're saying every time like we build any kind of object, Python's really asking me to do quite a bit here, just to make sure that anytime I would want to print the object, I need to have a fancy way of printing it as a string. And then these parameterized constructors, especially if you've worked with programming in other languages, for a language that's as simple to work with in many ways as Python is, one might hope that you wouldn't need something quite this bulky. Like this just looks like a lot. If you have that thought, don't worry. I want to say one more thing, though, before we carry on, which is there is at least a nicety here, which is that you don't need to call REPR of the object. You can just have the print statement of the object. And I actually have already done that with my circle, so I didn't call REPR on it. And you don't have to specify REPR at all. Python will infer that if you're printing something and you've written your REPR function, it will go ahead and call it automatically for you, which is nice. So even though I've declared an object using my parameterized constructor, I'm still perfectly capable of changing the attributes. So I can still change the attributes of each of these. And I'll show you. I might set r.width is equal to 2.0. r.height might be equal to 4.5. r.x1 is equal to negative 1.45. And let's set r.y1 is equal to 2.3. And if you don't believe me that these fields or attributes have changed, well, let's reprint r so you can see that they have. And you'll see here now that the rectangle started with this width and height in x1 and y1, and now we've set it to have the values that I just specified. Rotation's still picking up the default, of course, because we never set it. The next thing I would say, though, is once we can create objects and change their attributes, this isn't what we really want to do. What we really want to do is use these objects in the same way that we would use anything else that we work with when we program. And the short way of saying we want to do other things is to say, well, we want to use these objects with the building block of programming, which is the function. And so let's see how we would take this construct and adapt it into producing functions involving objects. Probably the simplest function I could imagine that would be reasonably useful involving these two shapes would be to go in and try and access the area of the shapes. So you'll notice that I didn't produce area as an attribute of either a circle or a rectangle. And the reason why I did that is in each case, I can infer the area from the fields or the attributes that I've already assigned. So if I were to store, I could say, I want to store as much as I humanly could about either of these shapes. I could add an area, and that's a float equal to 0.0. And I could add a perimeter, and that's a float equal to 0.0. And there's a host of other things that I might want to add as attributes of this shape. But that would be a very bad thing to do. And I guess I could ask you that as a question. So why would this be a bad thing to do? Why do I not want to add area and perimeter as two attributes of, in this case, a circle? But the same question is valid when we're considering a rectangle. Some great points. Okay. I don't know if I got the exact answer I was maybe looking for. There, Nadarajan is coming through for us. Good. All right. So there's a few answers here, and they're all good. John says not independent. All right. I like that. a few folks say they can be calculated from other attributes, which is true. That's good. So there is a notion of minimalism being an important paradigm of programming. Why store something if you can infer it or calculate it from something else? That's great. But redundancy, good job to the redundancy folks, because if you said redundancy, that's the critical answer here. So if I have a circle, for example, and I have set, in this particular case, the x and y1, x1 and y1 of the circle, you'll notice that I set the radius equal to 2.0. Well, this means that I could go in and I could print my circle dot area. That's a field of my circle, and I probably should say, okay, self dot area is equal to area. I'm going to get rid of perimeter because I can make this point without needing the perimeter. But I'll say that the area of the circle is, and what's going to get printed. Now, we know what the area of the circle is. It should be a function of the radius. So the radius is 2.0. So it's what? It's 3 times the radius squared. So it's 12. But actually what gets printed is that the area of the circle is 0. And that's because we have two ways of getting this area. So anytime you have two ways of getting something and they could disagree, you have wound up with a horrible object-oriented design. And so because of redundancy, you don't want to do this. Okay. So redundancy means that we want to retain a minimal collection of attributes for an object. And in general, if you can compute something easily from the other attributes, then you don't want to store it. This is nice because we're starting to see this notion of what is the smallest amount of information that we need in order to represent a rectangle. And you can see here, you can get the area, you can get the perimeter for free. So why would you need to store it? And so I'm going to remove what we have up here and say, I do not want to store this as a field. Instead, I want to infer it. If I want to calculate it, then this means that, well, I should probably have a function for doing so. So I could write a function called area, and it's going to take a rectangle. And here's where we're going to see, if you've started programming a lot in Python, this should feel like an old friend because, of course, I could have just said def area of R, but it's nice to have a type hint for our input parameter as well as for what it is that we're going to return. And we're going to have a doc string, I'm sure, that I could say, well, what does this do? It computes the area of a rectangle. I could be very precise and say it's going to take as an argument a rectangle object, and it's going to return a float, which is the area of R. Okay. And if this were the case, then we'd say return the product of the width of R and the height of R. So I can go in and access the two fields that actually will give me the area and take their product. And then I could do the same thing with creating a function to compute the area of a circle. So I'll call it C, type int as a circle, and it needs to return a float. And in this particular case, I could have a doc string here too. I could flesh this out, but I'll just say compute the area of a circle. I want to add all the args and return stuff, but I'll say I want to return what we said was the area of the circle, which is 3.0 times. In this case, it's a function of the radius squared. So we want to say c.radius. Two ways of doing this. I could just multiply it by itself, but remember that in Python we have a double asterisk to allow us to raise something to a power. So I can write it in this way, and now we get the area formula. Unfortunately, there's a problem here. What is our problem? What is our problem? John says error alert. Why error alert? Two functions with the same name? That's not what I was thinking. I thought that, especially with as much math as we did in part one, I thought you were going to be one of these people who tells me that pi exists, and I was going to have to go in and change this to math.pi, which I don't like, so I'm going to keep that as 3.0. But we have two functions that are named the same thing. And so the question is, well, what's going to happen if I try to go in and identify them? So let's say area of R is, and we're going to say area of R. And let's do area of circle. And we're going to say area of my circle. Okay. And let's save it and run it. I probably need a lowercase p for my print function. Save it and run it to see what actually happens. You might think that Python doesn't allow two functions with the same name. That's not quite right. So when I run it, and you say, well, something happened wrong. That's true. Probably what Python should do is formally not allow me to have two functions named the same thing. A lot of languages would do that. Python does actually allow this, though. And so if we look at our output here, what it's telling us is rectangle object has no attribute radius. If I switch these two print statements, you'll see, so I'm trying to print the area of the circle first. When I save this and run it, what you'll see is the area of the circle got computed. We said it was supposed to be 12, which indeed it is. And so the area of the circle got printed as 12.0. So Python was absolutely fine here. But it wasn't okay for whatever reason with printing the area of the rectangle. And it tells us, in both cases, regardless of the order of these print statements, that the rectangle object has no attribute radius. So the correct answer is not that Python doesn't allow you to name two functions the same thing. It's way more Python-y and potentially extremely devastating to your understanding of what's going on. The actual answer is that if you have two functions with the same name, Python ignores the first one. So it's just sort of like, I guess you didn't want that one, and the actual area function that you wanted was this. And just imagine for a second how frustrating the bugs are that you could get if you forget about the fact that, I don't know, you have a lot of code. And this is another good reason why you want files that don't have a lot of code in them. But imagine beating your head against the wall when you're looking at a function and thinking, I keep changing it and nothing is changing, only to realize that you have another function named the same thing beneath it with completely different behavior. So it should probably get angry at you, but instead it just allows you to do this, and that flexibility could create a lot of frustrations. The fix here is to say, well, what we're going to do is we're going to make sure we're going to have an inner mantra that we're never going to name two functions the same thing. So I can fix it by saying, well, I guess I could name this area of rectangle, and I guess I could name this area of circle, and then when I call these, I'm going to print the area of the circle, and then I'm going to call the area of the rectangle. And then when I save this and I run it in the terminal, what we're going to see is we're not going to get any errors because now you have two functions instead of one. And the area of the rectangle is indeed 9 because remember we changed the width to 2 and the height to 4.5, and I think the product of those two things is 9. Experienced programmers are going to know a better way of getting at this, a way that actually is going to allow us to name two functions the same thing, but that's a little beyond what I want to talk about right now, and we'll come back to it as we work with more advanced ideas and concepts in object-oriented programming. To carry on with our work with functions, I want to look at the example of, let's say we allow the user to move a function from one point to another, or a shape, I should say, from one point to another. In other words, we want to translate this rectangle, and this rectangle moved down and to the left, or this circle moved slightly down and over to the right. And if we were to change, or to change the underlying attributes of each of these shapes, in order to represent that in each case I'm moving the entire shape, say A units in the X direction and B units in the Y direction. So if A is positive, then I'm going to be going to the right. If it's negative, I'm going to be going to the left. If B is positive, I'm going up. If B is negative, I'm going down. And this is in my, Cartesian coordinate conceptualization of this. So if we're working with graphics coordinates, then you may remember that we need to think about this differently. We're starting in the top left and we go over and down. But regardless, say I'm thinking about this in classical Cartesian coordinates where positive values go over and up. The question is, how is it that I would write a function for this? And what is it about the attributes that would need to change? And I'll have additional functions called, in this particular case, translate, and I'll need to call them translate rectangle, and I'll need to call them translate circle, just to make sure that it's clear. I'm naming them two different things. And I want to specify that I've got a rectangle as input and two floats. So I called those A and B. I'll preserve that. I'm not going to return anything. The same thing's going to apply down here. So I'm going to say we're going to have a circle, C colon circle, A colon float, B colon float. It's not going to return anything. And let's write each of these functions as we go. So this function is going to translate a rectangle by shifting its coordinates of the point that we store. Okay, so we're going to move it by A units in the X direction and B units in the Y direction. We can move the entire shape just by changing this one point that we store. So in the case of the rectangle, it's a corner. In the case of the circle, it's going to be the center. And I could write a bunch of documentation here. I'm just going to say, in each case, I'm moving the shape. And the point that we store here is just the center. So both of these functions are going to be pretty similar, right? In this case, I'm just going to say r.x1 is going to have a added to it. So r.x1 plus equal to a. We get to use the shorthand that we've been using for a long time to change the value of a variable by adding something to it. And we're going to say r.y1 plus equal to b. And we're going to do the exact same thing for the circle, except I'm going to change r to c when I do that. And this allows us to change the position of each of these shapes. What I want to do is add a little bit of code to main in order to say, well, let's call the translate function and shift each of the objects. So I'll give it some distinctive values. Let's imagine that I want to translate both shapes. And in the case of the rectangle, I'm going to say, I've got my rectangle, translate rectangle. I called it R, and let's move it 2 units in the X direction, and we're going to use 4 units in the Y direction. And for the circle, well, I'm going to say my circle is what I called it. And in this particular case, let's change it to negative 1.0, negative 7.0. So I'm moving it 1 unit to the left and 7 units down. The question becomes, if I want to then go back and print R and print C, or print my circle, are we going to see a change? Where did x1 and y1 start here? So x1 and y1 here started negative 1.45 and 2.3. Are we going to see the circle have this go to 0.55 and 6.3? Or will it not move at all? And what am I asking here? What am I getting at? Good. All right, John, Lori, excellent. What is it that this is asking is really, are objects passed by reference? And we've seen that very briefly. So we touched on this in the lightest imaginable sense in part 1 of the course. I won't be angry if you don't remember. However, we have seen that the answer to this is yes. So when we work with integers, strings, basic built-in types like that, these are not passed by reference. So you're not able to change that variable inside of the function when you pass it into the function. You're changing essentially a copy. When we've worked with tuples, I think we've seen the same thing. Tuples are immutable, and when you pass them in, you're passing them in by value. But lists, maps, and now we see objects as well, are all going to be passed by reference. So when we run our code, we will see indeed that the rectangle has moved, and the circle has moved as well. So the circle started off with a radius equal to 3, or a radius equal to 2, an x1 coordinate that was equal to 1, and a y1 that was equal to 3. And so we moved it left by a unit, which took it to an x value of 0, and down by 7 units, which took it to a y value of, for the center, of negative 4. So notice that each of these functions specifically returns none. But when we pass an object into them, we're able to change the attributes of that object. That's a powerful thing to be able to do. And as we've said, how we have framed this is to say objects are indeed passed by reference. We're going to resolve all this soon because technically in Python, everything is an object. So wouldn't you think that everything is passed by reference? But everything is not passed by reference. So how I've said that objects are passed by reference is not quite right. The correct answer is passed by object reference, which is, sit tight for a full explanation. That's not something that I want to get into in order to simulate the force of gravity and look at some beautiful simulations of three-body problems. We'll see this all later, and it's all going to get tied together, but sit tight for now. Of course, what's the other thing I want to do? I want to be able to call both of these functions translate, and we're going to be able to do that as well, but we'll look at that in the next module of the course. For now, I need to say 2 more things about introductory object-oriented programming in Python and features that they give us. Python, first and foremost, has a special type of attribute that is universal or I should say assigned to every single member of the class that we create. So when we say this is the rectangle class, this is the circle class, these are the parameters that are associated with each of those things. So we're defining this object through its attributes. You could imagine that there are some things that are specific to individual circles and rectangles, but then there are other things that are attributes that we want every single rectangle to have. And so if I wanted to establish this, like for example, say that I wanted to, and I'm going to put this before my init function, before my constructor. Say I wanted to say every single rectangle that I'm ever going to encounter is going to get a descriptor, and it's going to be a string, and that descriptor is going to be boxy. All rectangles are boxy, fair enough. And all circles, well, let's do the same sort of thing for a circle, and say all circles are going to get a description attribute, which is a string, and that attribute is going to be the string round. So anytime I have any circle or any rectangle, I'm going to be able to go in and access that description. In fact, we're going to be able to access a class attribute in one of two different ways. First off, I'm going to go back to main and work with these two instances, R and my circle, of the rectangle and circle classes respectively. And I can go in and identify it. So I could say our rectangle is, and then set r.description. And when you call this and save and run, what you'll see is that the statement our rectangle is boxy gets printed. But you can also access a class attribute by accessing it with respect to the name of the class. So I could also say every circle is, and not my circle.description, but the circle class.description. So this is nice and convenient. And when I save that and run it, you're going to see that every circle is indeed round. I introduced this to you so you can see it because it's part of a complete understanding of how you define objects in Python, but also for a second reason, which is that you might wonder, what happens if I were to do something like, I don't know, change the description of my circle? So what if I were to say my circle's description is now orb-like? And I'll print and say, do I allow this to change? So when I say my circle.description, maybe you get an error, but actually Python is fine with saying that my circle now has a different string associated with its description. So far, so good. But then the question is, did I make a mistake here? Did I change the attribute of every circle by changing the attribute just of this one circle? So if I were going to say every circle is now, and circle, capital C dot description, then when I save this and I run it, I'll be able to see that I changed the class attribute associated with the myCircle instance of the circle that I created, but I didn't change the global overall value of that attribute. So our circle is now orb-like, but every circle is still round. So the class attribute is still preserved, which is good. That's point one that I wanted to point you to. Point two I want to point you to is, remember I said I'm not a huge fan of every time I create an object class, then I have to give it this parameterized constructor and make sure I've got a representation of it and so forth. And there are other built-in functions that are good practice for specific applications that all have the same standard names associated with them. All good. But other languages seem to have a nice, simpler representation of different objects. So to warm up what we're going to do with simulating gravity and prepare you for our next session, I want to see how to simplify this, because writing all these init and REPR functions is going to stink, especially when we're working with quite a few objects. And one of those objects is as simple as like an ordered pair object that just stores an X and a Y. So having to write all this stuff is going to be bulky. I don't want to do it. Wouldn't it be great if Python included this alongside the definition of the object? And in fact, it will. And so what I'm going to do is prepare you for that by showing you something that's actually, in the grand scheme of Python, not that old. So it's still relatively new. And what we're going to work with is called a data class. So I'm actually going to need an import from the standard library. And I need to say from data classes. I want to import two things. I'm going to import data class and I'm going to import field. Why I'm importing field is going to become clear. So for now, I'm just going to work with the import of data class. And let's go ahead and I'll put it right here above rectangle. Let me declare a specific class that is what I mentioned, which is an ordered pair. If I put at data class, and I've got this import statement, if I put it before the class declaration, then I'm going to get some things for free. So, and I'm also going to be able to declare this class in a much simpler way. Much simpler. Let me show you. Instead of needing a parameterized constructor, I'm simply going to say X is a float and its default value is 0.0. Y is a float and its default value is 0.0. Other languages make it super easy to declare object classes. The same thing applies here with Python, but you have to use a data class in order to do it. So this is kind of the old school way of establishing an object. And the newer way, at least in many applications of object-oriented programming, is to say, look, I've got an ordered pair, and yes, I could add a doc string and all that stuff too. But the ordered pair has an X, which is a float, a Y, which is a float, and they have the default values of 0.0. Much simpler, much nicer. I get init and REPR for free. That's the best part. So if I go into main and do one more thing, which is to say, let's set P equal to an ordered pair of 3.0 and 4.0. And let's print P. Then you can save this. And when we run it, we see that it gets printed in a nice form. So it's basically very similar to what I had before. But before I had to write this REPR function, now it's included with it. So that makes things way easier. And this, when we implement gravity, this is what we're going to use. I can also define something like a body object. So I'll go back up to my class declarations here and say, we're going to have an @data class. This class is going to call it a body. It's going to represent a heavenly body. It's going to have a name. That name probably should be a string. The default value is going to be an empty string. The mass is going to be a float. Its default value is going to be 0.0. We're going to have a position. And here's where I can use my ordered pair. So as what we're seeing is just as functions get modular, you can see this modularity starting to emerge with object-oriented design too. So I'm going to say we have an ordered pair. And it's going to start off as just an ordered pair, which means that it's going to get the 0, 0 default values. And I'll do the same thing for velocity and acceleration as I did with position. So we have velocity here, and we've got an acceleration, and this is all well and good. And maybe I want to make it a circle, so I'm going to make the circle have a radius, and it starts off as 0.0. And I could have tons of stuff here. I could color in the planet or the heavenly body and think about all sorts of things that we could add here. But for now, this is a nice tight representation. A body has a name, it has a mass, it has a radius, so we can draw it We can understand how big it is. This is going to be useful for computing gravity. We know where it exists. That's also going to be useful for computing gravity because I need to know, how far apart two things are in order to determine the gravitational force between them. All this is good. And the velocity and acceleration are represented as vectors. So we're going to have an x component and a y component. Go check out our reading on our Programming for Lovers website if you want this physics primer. That's not the direction I want to go right now. The direction that I want to go right now is to show you something, which is let's go to main and let's make a couple of bodies. So I'm going to have B1 and B2, and I'm just going to let them get all of the default attributes set for them. So let's go down and say, B1 is a body and B2 is a body. We're going to set B1's position, and I'm going to set it equal to 5.0, and let's print B1.position. All right, so far so good. And you'll see all this get printed nicely, so I'll save it, and then I'm going to run my code. And I actually get an error. So this is not going to be allowed. Why on earth would I have gotten an error here? Why would I get an error? Nothing I did seemed particularly earth-shattering. And all I did was create two bodies. I didn't even use B2. Just do it this way. I'm going to get an error this way too. Why on earth would this give us an error? Any thoughts? You need both parameters. What do we mean by that? Need an X and a Y? You mean when I declared my ordered pair? Let's see. Still an error. So it would give us the default values of 0 and 0. Perfectly reasonable thought. If Python were a very strict language, and it is very much not, but if it were a very strict language, this is the type of thing that you might imagine it might try to specify. You want an ordered pair? Well, you've got to tell me the fields. But Python's like, you told us, man. We got default fields all day. I can create an ordered pair and not specify these, and it's absolutely fine. And yet it gives us an error. Some people, do as learn good. It worked for you. Yeah. What's your Python version? What is your Python version? I'm going to go out on a limb and say it's not 3.14. I love bugs like this because the chat has no idea what's going on. There's like no reason whatsoever for this to give me an error, and it's not even giving everybody an error because what's going on here is a very Python thing. It is that when you create a class body, and you say the position also needs to be an ordered pair object. Okay. That ordered pair, what you think happens is you declare a body, and then that body gets its own ordered pair. But that's not what Python does. And I have no idea why this would be the case. Like when you design it, why they would have wanted this to be the case for these data classes. Certainly you would understand that the use case here that you should have is each time I declare a body, it gets a different ordered pair, but that's not what actually happens. And they've added error checking to it in newer versions of Python, I think, to prevent this, because it would be so easy in old Python. And if you have an earlier version of Python, I'm going to show you some code here that would cause it to produce some really weird behavior. So I could set B2 is equal to body. And when I try to print B1 dot position, if you also tried to print B2 dot position, you might think, well, what is going to actually get printed? It should be 0, 0, but that's not what you get. You get 5.0, 0.0. Yay, right? Thank you, Python. So instead of us having our own ordered pair associated with B1 and our own ordered pair associated with B2, and you change B1's position, and B1's position changes, but B2's position doesn't change, that's not what happens at all. So in earlier versions of Python, what you would see if you run this code, do is learn, you should confirm this for us, is that you're going to see 5.0, 0.0 get printed, because this statement changes the position of every body's position. Now, we see some weird Python stuff, right? This to me is maybe at the very top of the Python Phillip frustrations. And fortunately, they've said, you know what, we never give error messages for anything, but we are going to give an error message in this one particular case, because even though you tried to do this very obvious, natural thing to say, I've got a data class, here's my ordered pair data class, and the body data class is going to use that ordered pair object that I've just created, and I'm going to have a position, a velocity, and acceleration. Python's going to say, I'm only going to give you one ordered pair ever for a body. And you're like, well, but my simulation's going to have like 4,000 bodies in it. So you're telling me that the position of all of these bodies is going to be the same? And imagine, like, go back in time to the people before, this version of Python comes out and produces an error. And imagine trying to explain this to a beginner, because this would look so natural and obvious. All right. So the question is, what do we do? We can get around this. And the way that we get around it is to say, Python, we order you that you have to give a different ordered pair to every body that I declare. And we will do this by saying, I need the notation, when I set the ordered pair, it has to be field. And I'm going to delete everything else here. And now you're going to get to see why I imported field from data classes. So I need to set field. I have to write default underscore factory equals ordered pair. It doesn't even take up one line. And by, a stroke of genius, we've gone from code that's not tremendously pretty to very nice code. And now we're back in the realm of the hideous, which is, in order to specify individual ordered pairs for individual bodies and make sure that everybody gets their own, you have to write it in this particular way. So when I save this now and I run it, you will see we're not getting any error messages. Every circle is still round. And when I printed, I think I have a couple prints. I print the position of B1 and I print the position of B2. You'll see B1 moves, but B2 doesn't, which is exactly what you would want and is handled much more naturally by a lot of other languages. But goodness, what a thing to have to do. And fortunately, we're getting an error now, so it wouldn't even allow me to do this. But we're going to see when we work with data classes, guess what you're going to have a lot of? you're going to have a lot of a very normal thing, and then equal field, default factory, equal whatever the thing is that you want. Is that nice? No, it's horrendous. But that's just Python, right? And we love it. All right. One more little thing I wanted to show is, we get this data class that's generating a init for us, which is cool. But say I wanted to declare another body. I'm going to declare one more body. And in main, I probably shouldn't have put main at the very bottom. Oh well. In main, I'm going to declare one more object called B, and it's going to have the name equal to the sun. Yeah, let's B. It's going to have the mass equal to 1.989 E30, and it's going to have the radius equal to 696,340.0. Okay, in kilometers or whatever. All right. And so I've set these three fields of the body, and then I want to print it. Before, remember that I had to be a little bit careful about remembering what the order of the parameters is, and ensuring that the order of the parameters matches the order that was given in that constructor. What's nice about data classes is you're able to also specify what the attributes are that you care about. So in this particular case, I'm setting the name, I'm setting the mass, I'm setting the radius. I don't actually care about the position or the velocity or the acceleration. And notice that the radius, if we go back up to our declaration, the radius occurs last. I did that for a reason. So you'd see I don't actually have to specify the position and the velocity and the acceleration. In the data class format, it's not expecting me to say what these things are, or if I don't want to specify them, I have to move the radius up. I can put these in any particular order that I want. So I can even rearrange and say, I'm going to do the mass first, right? And put it that there, and then the name parameter is going to happen. So I can do it in any order that I like, and I can save it and run it. And again, I've got REPR included, so I get a nice print that's going to specify what these are. And you see the ordered pair gets these default values of x and y equal to 0 for the position, for the velocity, for the acceleration. But the parameters that I set, or these attributes I set of the radius, the mass, and the name, all got set when we passed in the parameters to the creation of the body. So in many ways, data classes, apart from this dreaded, horrific, hilarious Pythonic thing where we've got to make sure that we're not hitting an error message when we declare not just an object, mind you, but lists or maps as well. So that's the other thing that this is weird about. Like, you might imagine that an object obviously might want to have a list of other things as an attribute, but we're going to have to be very careful with that too when we work with data classes, because if you just tried to give this a list of strings, something like that, and you think that, I don't even know what this would be. Okay, stuff. Okay, body.stuff is a list of strings. It's not going to like this either. And that's because it's trying to establish one list for every single body that you possibly could ever imagine. We're going to get around that with the default factory stuff too. But my point is, it's not just for nested object declarations, it's also for lists and maps. So we're going to have to be careful. So we're going to save that and run it for now. Everything is okay. And things are getting printed. Even the ordered pairs are getting printed automatically because we used a data class. So REPR is included for us. And if we wanted something very exotic or special for such a function, then sure, we could, write our own class declaration. But for the purposes that we're going to need this for, when we implement gravity, data classes are going to do just fine, except of course for this weird thing, but that's all right. We can't have it perfect. To look ahead, we're going to say a lot more about object-oriented programming. So we're going to have 2 entire chapters of the course that are devoted to object-oriented programming. And sometimes you're not necessarily always going to want to use data classes. So we're going to talk a little bit about that too. When do we use them, when not? But for now, we are ready. We've seen everything that we need in order to implement our gravity simulator. This is going to be the start of what we can do next time, which is we have an ordered pair class and we've got a body class. And then we just kind of need more attributes in the body class, and we need like a universe class maybe to hold all the bodies in our simulation. You can add to this whatever you like. But we're going to see that next time. So we're going to need to implement gravity and apply that to see the moons of Jupiter, implement some 3-body simulations, see some cool stuff. You can go and read up on that, as I've said, on our Programming for Lovers website. Check it out. We've got our physics primer there, and we walk through all of this on a high level, on the level of pseudocode too, so you can get comfortable with how everything's going to work, because this is probably new to a lot of you, and thinking about, what are the constitutive attributes of an object, this is important to think through. And there's just as much design with objects as there is with writing functions and making sure they're modular and making sure that we have something that makes sense. So we're going to start with some starter code when we work with the gravity simulator, because I want to just build the gravity simulator and we'll already have our objects defined. So that's what we're going to do next time. And I can't wait because the simulations are really cool and pretty. But we'll have to do all this next time. I will see you then. Thank you for joining me. Like, subscribe, all that good stuff. And until I see you next, as always, happy coding.